to factorising expressions. I did one in the last video because I felt it was the most appropriate way of finding the missing length. Let's just adjust the camera. And that's it, you've done it all before. Let's just do a couple from question 1, factorising. So, I don't know, let's just do 1c. So 1c says this, I've got 20 minus 10p. The common factor of 20 and 10, of course, is going to be 10. So that'll be 2 minus 2p. 10 minus the single p. My mistake. So 10 times 2, 20. 10 times p, 10p. But of course it's negative. That's that one. I'll do another one. I've got 24 plus 18k's. Common factor of 24 and 18. I think I can get 6 out of that. I think is the biggest. So take out 6. 4 6's make 24. 3 6's make 18. But it's got a k stuck to it. And it's positive. Just check. 6 4's are 24. Yep. 6 3's are 18. Gotcha. No problem. Do a more dodgy one. I'll do J. I've got here 15 KL. That means 15 times K times L. And then I've got plus 27K squared. Let's decode it carefully. Now, I've got numbers and I've got letters. We can do it in one step, we can do it in several steps. If I take out my numbers first, if you want to do that, the common factor of 15 and 27 is 3. So I'm taking a 3 out, and I'm left with 5KLs plus 9K squared. That's okay, but it's not finished. You've got to factorise fully. And in an exam, if they tell you to factorise fully, watch out, that means you've got to take out the maximum from each of the two terms presented. So that's the biggest I can take from 15 and 27. Now look, I've got a k there and a k there. Therefore, if I take out a k from each of those terms inside the bracket, I'm left with 5l, because 3k times 5l would make 15k times l, 15kl. And if I take a k from the 9k squared, I'm left with 9k on its own. Therefore, 3k times 9k will be 3k times, what have I done wrong? And that's alright. So 3k times 9k will give me 27, k times k squared. So that's it, I'm back to the original. I just lost it for a minute there. Right, tiredness. That'll do. No, we'll do the last one. It looks scary. Do it down here. I've got 36 f squared, I think, times k. Take away 30j k squared. What can I take from that? I've got j's and j's. That's not an f, that's a j. Yeah, my sight is definitely going, but never mind. We'll do the maths. So I've got 36j squared times k minus 30j times k squared. Lovely, that's right. Right, let's just do the numbers first. 36 and 30. Oh, what can we take out of that? How about a 6? If I take a 6 out of that, I'm left with 6j squared multiplied by k minus 5j multiplied by k squared. Take out a j from each. Alright, so 6j. These means 6j times k, because j times j will be j squared, minus 5k squared. The j's been taken out as part of the factor outside the bracket. Now look, I've got a k to give and a k to give there. Therefore, I'm going to go 6 times j times k. That leaves me with, if I take a k out, I've got 6j there, and minus 5, and if I take a k from the k squared, I've got a k on its own. That should be a bracket, of course. Let's just have a quick check on that one. 6j k times 6j, 36 j squared k. Yeah, got it. Now over here, 6 times 5, 30, but it's negative. J on its own, yes. K times k, k squared. I've concluded that I don't like this method. I'd rather take out all my common factors in one step, because it's if I'm doing it in bits like this, it may induce an error. Normally I'd encourage you to obviously show where you're working, but when you're just dealing with one expression like that, which you have to factorize, it could be easy to take out what you need in one go and then decipher what goes into the bracket. Question 2, very boring. In each question, one side of the rectangle and the expression for the area has been given, and you've got to find the missing bit. Oh, I don't know, let's just do one of these little things here. Let's just do one. It's essentially factorizing. I've got a p out there, I've got a question mark here, and I know the area. I'll write it inside. That gives the area to the left bit. I'm going to write the area inside here. It's 7p squared minus 5p. So in other words, p times something makes that. So if I take out the common factor, there you go, 7p squared minus 5p. Take out common factor p, I'm left with 7p minus 5. Can't be done any further. I've factorised it fully. Therefore that's my p, that one, and therefore the length here must be 7p minus 5, and that's what question mark equals. Alright, I won't do any more of those. I'll look at question 3 though. I don't know why. Factorise fully the expressions for the area of these rectangles. Use your answers to give a term for the dimensions of each rectangle. Yeah, that's a little bit different. It's gone a bit further. So I'll draw you a rectangle, and this is question 3, page 42. It's only grade D. Alright? So the area is 5FG plus 8FG squared. Now remember, I'm trying to find the perimeter eventually. Yeah, the dimensions. In other words, what goes there and what goes there. So if I factorise that, that would give me, I can't take a common factor out with the numbers. I can take an F from you and an F from you, a G from you and a G from you. Right, so I'm going to take out an F and a G. What's left indoors? 5. What's left indoors? 8G. Study it. FG times 5, 5FG. FG times 8G, 8FG squared. So that's good. So what are the dimensions? Well, here I go. This must be 5 plus 8G. This side must be F times G. Doesn't matter which way around you put it. Really doesn't matter. Because when you multiply the two lengths, you'll get the area there. And these are its factors. One more if you want to. I've got a dodgy blue rectangle looking all intimidating like that. And the area is actually 6pq squared minus 2pq cubed. Yes, I've got that. Right, common factors. Take a 2 out of each. P and a P. Yep, take a P out of each. A q squared and a q cubed. The most I can take is a q squared. So let's just worry about what goes indoors. Well, that's negative for a start. 2 times 3 will give me 6. P times himself, but not relevant. It's just a single p on its own, and I've taken q squared out. Well, let's have a look. What is 3 times 2 times p times q squared? It will give me 6pq squared. Therefore, I really factorise that down. Now, what goes over here then? I've taken out a 2, I've taken out a p. I need a single q. I'll tell you why. Because 2 times p times q squared times q will give me my q cubed, alright? And that's it, I've fully factorised it. So let's say, for example, this length could be 3 minus q, and this length here is going to be 2pq squared, and that will work out to give this expression for the area there. Alright, no more of those. I remember doing question 6, something like it, for the foundation video, claiming to be grade C. I suppose it is, but there's nothing higher than that in this section, but I'll do you one anyway. I think these are a lot of fun. I'll do one. And this is question 6a. The expression in this box is 5y minus 10y squared. Then I've got a mystery box here, and I've got a mystery box down there, and then I've got a mystery box meeting in the middle like that. Then I've got a mystery box going upstairs like that, and a mystery box coming down here like so, and then another mystery box at the end. Now these are my instructions. Let's just change colour. At this juncture I must factorise. So clearly I'm going to get 2 factors, one in there and one in there. And at this juncture I must add. In other words, add these 2 factors and see what I get in here. And then I've got to factorise again. And then I've got to add the last 2 factors. This is, I don't know, almost meaningless. It's just having fun with factorising and then adding the 2 factors, and then we're just playing with algebra now. It's a great exercise. I'm only going to do one, so it'll take ages. Right, let's just factorise this thing down here, and then we'll whack in the answers in the box. So here we go. I go 15y minus 10y squared. I can take out a 5 and a y. Leaves me 3 minus 2 y's. Check. Yep, 15 y's. Y squared times 10. I'm happy with that. So I'm going to put a 5y there and a 3 minus 2y just there. Then it says add them. Okay then. So 5y plus 3 take away 2y. What's that going to give me? 5y take away 2y. It's going to be 3y plus 3. There you go. Very, very tidy. 3y plus 3. Now I've got to factorise it. Okay then. So I've got 3y plus 3. It's getting really easy. The common factor is 3. Gives me y plus 1. 3y. 3 times 1 is 3. No problem. So here are my two factors. I've got a y plus 1 upstairs and I've got a 3 downstairs. Now just add them. Okay. So I go y plus 1 plus the 3 is going to give me y plus 4, and I've landed y plus 4. So I've gone from here all the way to here, going through factorisation and adding and factorisation and adding, and that's it. You cannot claim that this is the simplified answer to that. It's got nothing to do with it. I just derived it from that through this procedure here. And that's where I want to stop with that. There's nothing beyond grade C. This was a really fun question. I like it very much. And it's grade C rated. So I'll stop there and I'll prep 3.3 and I'll be with you quite soon.